So you did this part, you did the p prime times this. You took the derivative of the second part, now you just have to take the derivative of
Okay.
q1.
And it's can't think of it.
It's just 1,
Oh.
right? Times
Right,
the
right.
second half, right?
Right.
It's just the product rule, right? Yeah, but that's right. So they just said p plus p prime times q1 times rho equal to c. And then we can then analyze whether this makes the market more or less competitive, right? So, for example, does the leader benefit from being the leader, right? Well, clearly they have to be, because they could always set their quantity equal to what they said in Cornell their quantity equal to. So they have to be better off than that, because they know that the other firm will just react as they would to the Cornell quantity, right? Okay, does the follower benefit from the firm being the leader? Well, that depends on whether it leads the leader to increase or decrease their quantity. The follower always wants the leader to decrease their quantity, right? Because that's better for the follower. They have less to compete with, right? And that's going to depend on whether the leader expects the follower to increase in response to an increase in quantity or decrease in response to an increase in quantity. If the leader expects that the follower will decrease, that is, if its strategic complements and pass-through is greater than 1, then that's going to lead to an increase in the markup, and that will be better for the follower firm. Right? And in what case is it better to be the follower than to be the leader? Well, exactly if the pass-through is greater than 1 as well, right? Because if you're the follower, you're going to produce, the leader is going to have to reduce his quantity, and that's going to benefit you more because you can sort of fill the gap, right? And is society better off from the firm being a leader, or would it be better off if there was just Cornell competition? Well, it all depends on, again, the pass-through rate compared to 1, because if that's greater than 1, right, then that's going to mean that this term, which is the difference between the price and the marginal revenue, that's the monopoly problem, right, is going to be greater. If the pass-through is less than 1, then this is going to be smaller than what it would be. Okay. So I think that this suggests a pretty natural alternative way that we can think about conjectures, about how to measure them. Which is that, if you think, how does a firm form its conjectures about, how other firms will respond to what it does? Well, it probably looks at other times in the past where its costs went up and therefore it raised its prices, right? And it uses that as a way to figure out what will happen if it raises its prices now, right? So why don't we as economists do the exact same thing, right? Look at cases in the past where this firm raised its prices and see what other firms did, because that's probably how the firm is figuring it out anyway, right? And this hypothesis is called consistent conjecture. If a firm conjectures that the other firms will respond in the way that in the past, when the costs rose, and the firm increased its prices, that led other firms to change their prices, then the firm is said to have consistent conjectures. And this is due to work in 1981 by Tim Bresnahan. If you think about it, the other models are actually a little bit strange. So in the Cornell model, I know that if I increase my quantity, the firm might say decrease their quantity. And yet, I assume that they're holding it fixed. That's a little bit weird, right? So this is also very convenient from an empirical perspective, because it means that if we observe things that change the firm's cost, we can actually measure the conjectures. And that's the same things that will allow us to measure demand, which we need for other reasons as well. Anyway, so anyone who wants to go can go, but I'll just finish up by explaining this as you leave. So this lets us isolate, it's a bit like the monopoly model. Consistent conjectures lets us isolate the relevant part of the market we care about. So if we're looking at a single firm, we're only interested in their behavior. If we have a shock to the cost of that firm, we can estimate their residual demand curve by just seeing, given what all the other firms do, what ends up happening to that firm's prices. That's what the firm's going to care about, because that's what will happen if it raises its prices, right? And this was a strategy used by Baker and Bresnahan in 1988. They applied it to the brewing industry using changes in transportation costs for individual firms because they had changes in roads and stuff. When we talk next class about the merger between two firms, the key thing is going to be that if we just have changes in the cost of those two firms, that'll allow us to measure everything that we care about for those two firms. Because, yeah, all sorts of other things will move around, but that's what those two firms are going to take into account, right? Because they're going to think about when a change in their cost happened, how did that lead all the prices to change? And it allows you to separate them from all the other firms in the industry, which makes things a bit simpler. And you can apply this more broadly. You can apply it to thinking about quality. How do the other firms change the quality of their products when I change my price or my quality? And thinking about lots of other things like antitrust. This approach, which I think makes a lot of sense, got historically lost in the oligopoly literature, but I think it is a pretty interesting and a great opportunity for a senior thesis to do more thinking about this. So, thanks. Yeah, again, turn in your problem sets. If anyone who is doing well in the class would like to be a TA again, RA, let me know. I'll try to set that up.